We multiply one matrix by another matrix. It's not like adding them, though, where you do it entry by entry. It's more unique, and pretty cool once you get the hang of it. Here's how it works. Let's say you have two matrices. Let's make both of them 2 by 2, meaning 2 rows by 2 columns. Write the first matrix to the left, and the second matrix goes next to it and translate it up a bit, kind of like we're making a table. The product we get when we multiply the matrices together will go right between them. We'll also draw some grid lines to help us along. Now, look at the first row of the first matrix and the first column of the second matrix. See how there's two numbers in each? Multiply the first number in the row by the first number in the column. 1 times 2 is 2. Now do the next ones. 3 times 3 is 9. Now add them up. 2 plus 9 is 11. Let's put that number in the top left position so that it matches up with the rows and columns we used to get it. See how that works? You can do the same thing to get the other entries. -4 plus 0 is -4. 4 plus -3 is 1. -8 plus 0 is -8. So, here's your answer. Not all that bad, is it? There's one catch, though. Just like with addition, your matrices have to be the right size. Look at these two matrices. 2 times 8 is 16. 3 times 4 is 12. 3 times... Wait a minute. There are no more rows in the second matrix. We ran out of room. So, these matrices can't be multiplied. The number of columns in the first matrix has to be the same as the number of rows in the second matrix. As long as you're careful to match up your dimensions right, though, it's pretty easy. Understand
Of your product in such a way that it's very difficult to make mistakes. What we're doing is basically setting ourselves up for success, okay? So I'm going to take the way that you multiply matrix. Let me go over that first before I show you how to do this. Is you multiply the row in the multiply matrix by the column of the multiplicand matrix, okay? You multiply it like this, and then you do that, and then you do this, and then go to the bottom, and then that, and then bottom, and then this again. You keep doing row times column, and that's how you get your answer. So that rotation back and forth between rows and columns in the multiply matrix and the multiplicand matrix leaves a lot of room for mistakes and disorganization, okay? So that's why I want to show you this cool trick. So just remember that you multiply the rows of the first multiply matrix with the column of the multiplicand of the second matrix, okay? Now, with that in mind, let me show you how I'm going to set this up. What you do is you take the rows in the multiplier matrix and write them as coordinates, okay? This is a 2 by 2, so let's write it as a x two-dimensional coordinates. 2 by, so it's 2 comma 4 for the first row. 2 comma 4, and then for the second row 1 comma 5. So in 2 dimensions you can think of this as xy. All right, now this is the cool part. We're going to write down the columns in the multiplicand matrix in a horizontal orientation. All right, so 3 2 is a column in this second matrix right here, so I'll write it as 3 comma 2. All right, and then 5 1, I'm going to orient it in a horizontal fashion, 5 comma 1. All right, so let's go over this again. The multiplier rows, the rows in the multiplier matrix, you write them just as is, but the columns in the multiplicand matrix, the second matrix you're multiplying by, you just orient them horizontally. Okay. All right, now that we have it set up like this, is a piece of cake from here on out. So what we're going to do is basically multiply the numbers by multiplying corresponding coordinates. Okay, so x times x, y times y, and you find the sum of the products. Okay, so for this coordinate and that coordinate, that's going to go into the first entry. 2 times 3 is 6, plus 4 times 2, 8. Okay, plus 6 plus 8, 14. So that's the first entry in our resultant matrix. And then the next one, you go 1 times 3, 3 plus 5 times 2, 10. 3 plus 10, 13. Next one, 2 times 5, we multiply the x's. 10 plus the y's, 4 times 1, 4. Add it up, 14. Okay? And then the next one, we have 1 times 5, 5, plus 1 times 5, 5. Add them together, you get 10. So your final matrix, the product of those two matrices, is 14, 14, 13, and 10. All right, so there you have it. All right, let's take a look at another example just to make sure we have this down. Problem number 2. So let's find the product of the following matrix: 2, 3, 1, 5. Find this times 1, 2, 2, 5, and then 3, 2. Okay, now, first of all, we don't just blindly multiply. We have to determine if the product is defined. So let's go ahead and determine that real quick. This is a 2 by 2 matrix, and this has 2 rows and 3 columns, 2 by 3. The column from the multiplier matrix is equal to the row of the multiplicand matrix. So that's excellent. So that means that we can multiply these two matrices. All right. And the resulting answer, the answer for our product is going to be a 2 by 3 matrix. So we can keep that in mind. So since the product is defined, let's go ahead and find the product. Okay. Now let's set up our grid like we did before. We have 2 rows for the x, for the multiplier matrix. And then for the multiplicand matrix, we have 3 columns. So we're going to make it sufficiently long to compensate for that size. All right, so for our multiplier matrix, we're copying the rows down as is, write it as coordinates 2, 1, and then we'll write down the row, the second row in the multiplier matrix, which is 3, 5, and then now we're going to copy down the columns in the multiplicand matrix. Okay, so don't forget this is the multiplier matrix, multiplier. And then this is the multiplicand. Now, you might wonder, why am I labeling them multiplier and multiplicand? The idea here is that multiplication of matrices does not commute. So A times B, matrix A times matrix B is not equal to matrix B times matrix A. So you have to be really careful with the order here. All right, so that's why I'm distinguishing them by their titles. Okay, so now let's copy down the columns of the multiplicand matrix. They are oriented vertically, but we're going to reorient them in a horizontal fashion. All right, so we have, what do we have here? 1, 2. Write this column horizontally, and then 2, 5, and then lastly 3, 2. Now let's go ahead and multiply. We're going to have, we'll multiply the x's and the y's for each intersection. So these two intersect here. 2 times 1, 2, plus 1 times 2, 2. Answer equals 4. I hope you see how they are intersecting here, because this one and this one, they meet right here. So that's the 1 point plus 1, 1 spot. So that's how I'm doing it. Now the next set, this times this goes down here. It's just like a typical multiplication grid, right? So 3 times 1 is 3, plus 5 times 2 is 10. Sum, 13. Next one, 2 times 2 is 4, plus 1 times 5 is 5. 4 plus 5 is 9. 2 times 3 is 6, plus 5 times 5, almost root 10. 5 times 5 is 25. Sum is 31. And then last column, 3 times 2 is 6. Plus 1 times 2, 2. 6 plus 2 is 8. And then 3 times 3 is 9. Plus 5 times 2, 10, which is equal to 19. So the beauty is the multiplication and addition, they're all organized in this setup. Okay, everything is inbuilt in the setup, so it's it's hard to make mistakes, basically. All right, so that's the beauty of this method. All right, so let's go ahead and write down what our resulting product is. It's going to be 4, 9, 8, and then 13, 31, 19. Okay, so that's an easy way to multiply matrices.
Write a method in which you don't have to use your brain. It is very easy method, but there is a writing work. For example, write row wise. There is 1 2. Write 1 2 1 2. Next row is 3 4. Write down 3 4 3 4. What is the column? You can observe that column is 5 7. So 5 is the first, 7 is the second. Write down 5 7. For a column, the pattern is this way: 5 7 5 7. Next is 6 8. So write down 6 8 6 8. The pattern you need to remember is write row wise: 1 2 1 2 as it is, 3 4 3 4 as it is. For a column, you have to write it as a columnar wise: 5 7. So that's why 5 7 5 7. Second column is 6 8. So write down 6 8 6 8. And that's it. This is my answer. One student requested about how to solve matrix multiplication simply. So this is the method. Generally, I don't use this method. I can do oral calculation for all these. But if you are a beginner, this method is helpful for you. So our final answer is. So this is my final
Matrix,
answer.
and many of them hanging out together, matrices. Matrices are everywhere. They are all around us, even now in this very room. Sorry, let's get back on track. Matrices really are everywhere, though. They're used in business, economics, cryptography, physics, electronics, and computer graphics. One reason matrices are so cool is that we can pack so much information into them and then turn a huge series of different problems into one single problem.